morning, everyone. Sorry for the delay. Today we're going to talk about MobX State Tree. The title of the talk is, you already know that, you don't know MobX State Tree. First of all, who I am. I'm Gallo, Principal Engineer at DAZN. If you don't know DAZN, we're a live sports streaming company based in London. We're live in 5 countries. We're trying to be the Netflix of sports. Twitter, website, feel free to contact me for everything you find interesting or not interesting in the presentation. The plan for today. So we'll start with a MobX intro. So even if you haven't heard about MobX yet, you'll get an intro about it. And then we will move to MobX State Tree overview and how it works. Then we are going to have a look at how to design a reactive project. So how to actually set up a project using MobX State Tree. And then a couple of hints and best practices to keep you home, to bring you home. So first question is, which is the difference between MobX and MobX State Tree? Like most asked question ever. Is like, if MobX is the engine, MobX State Tree is the car. So MobX is actually powering MobX State Tree. In order to arrive exactly to what MobX State Tree does, let's start with MobX first, with the engine. MobX has one simple goal. Well, it has multiple goals, but at the beginning, it was born with the idea to help you decoupling your view from your business logic. That seems like an obvious thing. Everyone is happy to say, oh, I really want my view to be separated from the business logic, but when actually we go to hands-on code, it's not always like that. Then it uses reactive paradigms to such as like observer, observables, and it allows you to get into the reactive world without knowing much about it. So I think it's a great entrance for anyone that is not really familiar with the reactive world, and it's something you can start with. And third is unopinionated. What exactly that means is that MobX doesn't give you a full solution, a ready solution, or how to handle your state. It contains a set of tools, a set of functions or utilities that you can use to handle your state, but it doesn't give you a linear flow for action, dispatching an action, reacting. It just gives you some pieces. And this is why MobX State Tree makes sense. We will see that in a bit. Let's start with MobX. There are 4 core concepts. First is the observable state. So MobX has its own state. You can store your state into MobX through observable. Of course, it's mutable, so if you come from the Redux world, this is slightly different. Redux was almost all about immutability. In this case, we're talking about mutability. So your state is actually inside the mutable application state, which is inside unobservable. We will see that in a minute. Computed values are super important, and they are automatically derives value. So we are not storing anything into a computed value. They are simply derivation of the mutable application state. Then we have the observer, as you can see that with the notation, with the decorator is the easiest way to subscribe to an observable. And then we have reactions. Reactions are something that includes everything that is a side effect. So when we have an observable state, we have something that could change because it's mutable. So we need something to listen to that change or to those changes and to react. Those are the reaction. Those are quite far from reality. That's why we probably need some code. I hope it's visible. Can you see it more or less? So first of all, observable state. Well, let's start with the goal. So the goal here is to have a car park, which is our store. Not our store. Our model where we want to store our things. And then there is a view, car park view. So in the car park, we have an observable array of cars, which is an empty array. We initialize it as an empty array. And then we have a computed value, which is how many Ferrari do I have? Because you should be always aware of how many Ferrari do you have in your car park. So as you can see, the first one is unobservable. And so we are back to observable state. So first thing, done. Observable state, I define a class, I use the decorators. If your project doesn't support decorators, it's fine. There are more syntax. There are slightly different syntax, but the concepts are exactly the same. And then we have the computed value. Computed values are interesting because in this case, I'm taking the array, I'm filtering by the isFerrari function, and then I'm taking the length. This is exactly what a computed value is. So it's reading from the cars array, and it's outputting something that is a derivation starting from cars. Straightforward so far. This is quite easy. The view is not that interesting. The only way to notice is that inside the car park view, which is a plain old React component, we added the observer, the decorator at the beginning, and that is actually what observer is, so subscribing to observable. What that means for a React component. A React component is all about rendering itself, about calling the render function. But when should I call the render function? With observer and with MobX, you're actually saying that every time an observable inside your render function changes, your whole component re-renders. It feels like a little bit magic at the beginning. The first time I saw it, like, okay, so I don't have any power to control exactly what's going on, but exactly the power is inside all yours observable. You can control them, you can leverage them, you can use computed values, and so this component here, car park view, which has a map showing rendering a car, and then it's showing how many Ferrari do I have inside the car park. As we can see at the bottom, we have a classic render function. So car park, element root, standard React things. And then an interesting thing is that we are updating the model with a set timeout after the render function. So usually up to this line, this was plain old React. We're passing props, we're using props, we are printing stuff, everyone is happy. The nice thing is that actually if you run this code, it will re-render the component because I'm updating an observable array. So observable array is updated, React component is re-rendered, your view, it's done, it's finished. I don't have to do anything else. And this is more or less the whole thing about MobX. We have observable state, computed values, observer to subscribe to observables, and reactions. That's it. I don't want to spend more on MobX. Those are the 4 concepts. So I would like to move a little bit forward and talking about MobX State Tree and why we need that. Because you saw MobX and you saw that it's powerful enough potentially to almost build whatever you need to manage your state. But you need some order. You need some rules, more or less. That's why the first thing that you will find about MobX State Tree is that it's opinionated or ready to use. Compared to MobX, MobX State Tree gives you a way to handle the process. So it uses MobX behind the scenes, but it tells you, oh, you know what? If you want to update something, you need to do this. If you want to react to something, you need to do it in this way. And this is just for helping you creating a project in the most efficient way possible. Again, it's powered by MobX. I already said that too many times. And it relies on the concept of trees. That's why it's called MobX State Tree. But also, you can find the word store, which is the same of tree. I know it's a little bit confusing at the beginning, but whenever I say store is a tree, whenever I say tree is a store as well. What is a tree? I'm giving you a lot of notions, but we will arrive to something more meaningful. So a tree is a composition, not a composition, sorry, is made of 3 different pieces. The first part is the model. The model is a mutable observable state. Again, you may remember from 2 slides ago, MobX. That's plain MobX, nothing changes. This is an addition. It contains type information. So as you can see here, for example, this is the model. This is the model of a car. This is one property. And then there is type string. So I have to specify which is the type of the of my property, of my observable state. And then there could be nested trees. So a property, the model could contain other trees. Fine so far. Observable state, MobX, typing information inside, and we could nest more trees. Then we have views. Views are exactly 100% MobX computed values. Again, we can see here car store. Again, type car, name string, etc. And then we have views. Views, it's returning a getter, which is Ferrari, which is just checking if the name using the self. They use this syntax to avoid these the confusion with this. They're using self. So self is straightforward to tell you that self name dot includes Ferrari, which is actually is Ferrari. So you can straightforward use car dot is Ferrari to find out if it's a Ferrari as well. And you can start seeing why MobX State Tree is built on top of MobX, because I'm saying basically the same thing twice, more or less. And then we got actions. Actions in MobX State Tree are the only way to update your model. So how you can actually update your model. In the MobX example, I was simply going to pushing a new element into the array, as I showed you before. But in this case, we are talking about calling a function. And that function is allowed to change your model. As you can see, again, not going with the car store, but this is the car that we just saw. Then we have a car park store, which holds an array of car. As you can see here, we have types array, which is specifying that I need an array of types car. Nothing really far from rocket science. And then I have a computed property, which is how many Ferrari, which is simply counting the length of all my cars that returns is Ferrari as true. And then we got the actions. The only action that I have in this example is add car, because before I was adding car by pushing to the array. Right now I'm adding car by calling an action. So how do I initialize a MobX State Tree store? With the create method. So you do car park store dot create, and you pass the initial state. You may have an initial state, you may not have an initial state. If you want, is the first parameter. You pass it, that's it. And then how do I update a store? I update a store thanks to actions, which are in this case car park store, which is the variable I just create, add car, name, whatever name you prefer. And bear in mind that here I'm passing an object to add car, and that add car is not making any assumption here, here yet about what I'm passing, because here I'm still pushing to an array. But what's going on behind the scene is that since this is an array of cars, I can't really pass anything to add car, because if I would pass, I don't know, an object with a different structure or a different without name, for example, this code will complain, will throw an error saying, oh, sorry, that thing, that object that you told me it was a car, it actually wasn't. So there is the runtime check on your type of the properties that you're using inside your store. This is the store, more or less. So far we learned that similarities with MobX, and we got type information for the properties, and then we know that we can nest multiple stores in a tree. That's why it's called tree. You can have as much level as you prefer. So this is fine. This is a store, but how do I actually use it within my React components? There are two files involved. The one on the left is your old friend app.js. Everyone has an app.js, root.js, or something similar. We have the React DOM render function. The first parameter is usually our app. And our app, in this case, is actually wrapped by a provider. You may remember that from Redux, similar concept. There is a provider. We are passing information to that provider. In this case, we are passing two stores. For example, shop stores. I create my instance of a shop store here, and then I'm passing it to the provider, and that's fine, that is completed. Once that step on the left is done, I can go to my component and do this inject here. This is a plain old React component, classic, nothing changes. I'm just using inject. What does inject do? Inject is going through the whatever I provided to the provider, and is checking if there is something named shop, and it's making that available. It's bringing that available into that component. How do I access that? Through props. So if you do these.props and you get shop from here, you can read shop.checkAmount for a example. So we learned that we can use inject and provider to inject stores within components. It's perfectly fine that you can inject everything everywhere. It may feel a little bit, okay, there is too much freedom. I don't like that. But it's actually up to you, what do you want to inject. But it's also very important to be aware that it's not only about the injection. The injection is giving you the possibility of reading those variables or calling actions or doing something with the store. But what's going on here, it's again, the observer decorator here is telling us that this component will re-render again if there is an observable that changes values inside its render function. So the combination of the injection of a store and of the observer will give you enough power on each component to decide how to re-render itself. It's very important to remember that having multiple observers, having a lot of observers in your app is better than having one observer. Because if you have a lot of observers around your app, if every component is actually an observer, almost every component, you have every component responsible for its own re-rendering. Instead, if you have only one giant observer at the beginning, every time something changes at the nested level, you need to re-render everything. And React, as soon as you render a root element, it tries to re-render the whole DOM tree. And of course, there are smart algorithms going on that will prevent you to render that on actually in the DOM. But the React stuff is still going on. It's still burning your memory, still occupying stuff that we don't want to. So a lot of observers around your code are fine. It's actually a recommended way on how to optimize an application with MobX. Let's keep talking a little bit about MobX State Tree stores, because I show you what a store does basically, but it has more feature. A store, so far we talk about mutability. So you have your state, you can change it, you can update it, it's mutable, and you have reactions that are reacting to it. But a store is also immutable because there are automatically generated snapshots out of that store. So every time you perform an action, you can register. You can, first of all, take a snapshot, or you can register to an event which is like after action, you can get the snapshot of your store. And that means that at every time, any time you need, you can create an exact snapshot of your store. And that leads us to a couple of nice features. First of all is time traveling. Time traveling because imagine you have your current state, you are applying, you're doing one action, your state changes, you have another state, another snapshot. With those multiple snapshots, you can go back in time, go forward, do whatever you want. You can still snapshotting, you are still snapshotting and applying the snapshot, and that's quite useful. And also snapshots are, of course, we are talking about serializable objects. So a snapshot could be stored on the server side, because maybe the second time the user is back into your application, you want to provide the same exact state to the whole app. Snapshot will be your friend to deliver that feature as a matter of minutes. Very important feature is composition. So you can actually compose different stores. Why composition? Composition will help you having different, will help you reuse part of your code. We will see an example later. And also we will help you thinking in a more separated way. So you can have different stores working on different things, and then you can compose them into something more complex, but that doesn't hold the whole complexity. Lifecycle method, I briefly mentioned that already. One store has all the things that you can expect, such as after create, before destroy, or some helper function that you may need to use while using MobX State Tree. And last but not least, dependency injection. Imagine the scenario where you want to use a library to doing requests, for example, or you have your own separated modules, which is all about performing requests to your backend. It's setting up all the JWT token, all your authentication mechanism, and you don't want that part of the code to pollute your store, because your store is about something else. You just want to fetch data. That's it. This is a useful case for dependency injections. Let's start with the example this time. Again, car park store, same car, same array, car store, same thing. The different thing is that right now I have an action which is download cars. I need to fetch some data from my server. I'm downloading the list of cars that I have. I'm using this function here, getEnv, which is still available in MobX State Tree, using self, and then using getCarsFromBackend method. Where that method comes from, because if I only show you this part, there is no trace of that. No one is telling us where it comes from. It's actually coming from here, from the creation time. At creation time, as I told you, the first parameter is the initial state. So the initial state is an array of cars, in this case. The second parameter is the environment, is the thing that I'm injecting. So in this case, I'm injecting an object which contains a variable called getCarsFromBackend, which is a function that will help me downloading all my cars. In this case, I'm injecting something, so it's useful also for testing purpose. Imagine you want to test your store. You do an easy carparkstore.create, and you can pass, instead of the real getCarsFromBackend, you can pass a mock version. You can pass a function. You can pass, in this case, a function that returns a promise that does immediately what you need to do. That's why it's useful for testing. One core concept is that environment is shared per tree, which is written here, which may be, okay, yeah, it's shared per tree, but it's actually a core concept, because we will see later how that could help us or how that could annoy us a little bit in some configuration. So in this case, also inside our car store, I can do getEnv self.getCarsFromBackend, because the car store is part of this tree. So this tree contains the car park store and the car store, which is the children of that element. So the environment is shared among all the tree. That's fine. We saw a little bit, the theory part is almost over. We are now going a little bit more hands-on. So you saw MobX State Tree, you saw MobX, you said, okay, maybe I'll give it a go. I would like to think about my project in a more reactive way. I would like to leverage MobX and MobX State Tree to create my next project, maybe. What should I decide? How can I start? So there are two things that you need to think about while structuring your project. And the first one is shape your trees. So there is one the decision that you need to make, which is choosing between one root stores and multiple root stores. We'll see in a bit what that means. Second point is store communication, how stores communicate between each other. Because in an ideal world, each component is related to more or less one store, and that store only contains stuff that things that are self-contained to that store. But that's not the real world, and in your real world, you will need one action that involves three stores. because you may want to update your navigation, or you may want to update your UI, may want to update your local storage. So we need to handle how stores communicate between each other, because we want to put that kind of communication at store level. Your component shouldn't be aware of what's going on behind the scene. Let's start with deciding between one root store or multiple root stores. If you remember, the provider tag here is the one that we had in the app.js. And this is the way we are including one root store. This root store could contain many stores, like, I don't know, navigation, car park, again with car store, language store, whatever you may think. The core concept is that there is only one tree in this case. One tree, and the root of this tree is the root store. So let's see pros and cons. So as a pro, it's easier to perform action on the whole tree. So imagine you need to take a snapshot of your whole application. If your whole application is in one tree, you take one snapshot. That's it. Boom, done. Same for creation, destroy. It's simply easier because your whole application is in one tree. And also, there is a unique environment for the dependency injection. Again, if you remember dependency injection from before, it's shared per tree. If I have one tree, it's shared everywhere. Easy. As a cons, we need to make sure that with this configuration, we are not creating stores that are too tightly coupled between each other. Being in the same tree means that from the MobX APIs, MobX State Tree APIs, there are ways to navigate and to traverse through the tree. You can do stuff like get parent, get children, go left, go right. But that means that you can start having stores that knows about the whole structure of your project, and that's not going to helpful for you, especially if you want to refactor or reconsider different areas. Multiple root stores. What does that mean? There is, again, provider, and the provider this time doesn't have a unique children. Not children. We're not passing one prop to the provider, but we're passing multiple props. In this case, we have 3 stores and 3 trees. And pros is that it's easier to reason by domain. So in this configuration, my language store is not affected by anything. I don't even know where that should be. When I think about my language store, I think it's self-contained. It doesn't need anything from the outside. Same for the car park and for the navigation store. As a warning, we need to make sure that it's less, well, we need to be aware that it's less immediate to perform actions on everything. For example, again, a snapshot. If you need the snapshot of your whole application state, in this case, you need to take 3 snapshots, which is, you may want to, you may don't want to, it's up to you. There is not a right and wrong thing. The creator of MobX and MobX State Tree say that it's perfectly fine to use one of the 2 combinations. Just be aware that in this case, if you need to perform a lot of actions of your whole state, you may need to do that on each single trees. And again, since we have multiple trees, the dependency injection, our environment, is not shared among different trees. Each tree has its own dependency injection. So if I'm injecting something here, I have to inject it here as well if I need to, and here as well. So I need to do that three times. One root store, multiple root store. This is mostly up to you. From a practical point of view, if you have a lot of complex state and you need to rely a lot on the snapshot of your whole application, I would probably suggest you to go a little bit more on this configuration. If you don't think you're going to use snapshot that frequently, or you need snapshot only on a subset of your application state, probably this configuration will help you thinking and will help your mind reasoning by domain a little bit more. I told you that we need to talk about stores communication. Stores communication is something that is needed, and we don't want that communication to happen at the view level, because we want the complexity. As I told you, the first goal of MobX was to remove the business logic from the view. So stores communication has to rely into the stores, not into the components. We have multiple, but I'm going to show you 3 different approaches to this problem. First approach is the default approach. The default approach is where each store accesses directly other stores. And we are talking about the configuration when we have one root store and my computer. Yeah, probably not mine. I'll try to continue in the meanwhile. So the default approach, we have one root store which contains few stores. Imagine that I have store A, which is the root, store B, and store C. My store A wants to talk with my store B wants to talk with store C for whatever reason. What the default approach suggests is to pass through the parent and go to the children. How we are going to do that? With the method that I told you before. You can actually navigate through the MobX State Tree through the tree. So you can do stuff like this is the root store. The root store has two children, nav store and page store. And the page store, in order to talk with the nav store, what it actually does is that it does get parent self dot get nav store, and then it calls one action that is not relevant for this purpose. So in this case, what I did was going from here, I went up, I went down, and I called a method. In this way, I'm communicating between 2 stores. This is easy. You will see that in a lot of example. On day 1, you will probably write something like this. It's straightforward. Be reminded that these, each store could end up knowing everything about your world structure. Imagine if you start to having 6-level nested stores and you start doing get parent, go down, get parent, go up. You suddenly have one store that knows about the whole structure, which you really don't want that. Second approach, actions wrapper, one store to rule them all. So imagine we have a login action. As I told you, a login action typically may have different things involved. You want to update the URL, you want to change the UI, you want to do something else. In this case, this solution creates a store that contains only action. It doesn't have a single property, only holds action. And those actions are calling directly other stores. So what you have is that you have a unique interfaces. So from the component point of view, you just do actions wrapper store dot login, and what happens behind the scenes is not up to the component. That's the nice thing. The component just knows that it needs to log in. This component instead knows a lot, because in this case I'm simply calling 3 things. But imagine that if we start doing if this store has this property, go to that place. If store X has another property, this store could be really, really big and potentially could know your whole application, could know everything. So you really don't want that, because again, if you have your whole application code or your whole application business logic into one store, it's like it's not going to work very well. Third options is using and leveraging dependency injection. In this case, I told you when we talk about dependency injection that you can inject anything. So why not injecting stores into other stores? Still an injection. How I'm going to do that? So in this example, on the left, we have a region store. Nope. We have a region store. The region store contains a type string, which is UK. The type optional means that you can set up a default, which is UK. And it's very small, just the region. And then we have navigation stores that instead contains one property, which is path, and 2 views, one that is region and one that is URL path. My final goal is to have the URL that looks like region/path, because my business decided that that was the right thing to do. So how can I achieve that? First of all, I create the region store. Right, this is not really working. I create the region store here, and then I create the navigation store, or maybe not. And the navigation store, the first parameter is always the initial state, the path login. The second parameter, in this case, I'm still doing the dependency injection, but I'm injecting another store. So nothing really magic is going on. I'm still doing the same thing. I'm just passing a different object. What is happening is that thanks to the getHelp util method that we saw before, I can do stuff like getHelp senf.regionstore.region. I'm reading which is the region. I'm making it available with the region getter here, and the URL path could be could return self.region, which is this guy here, /self.path, which is this guy here. In this way, I created one store, my navigation store, which is depending on another store, which is region, but they are not tightly coupled, because I'm explicitly saying, oh, in order to work, you need an object named region store, which has this shape, which has this, has this feature. I show you the example using views, so using computer properties, but you could use actions as well. It works exactly in the same way. With this configuration, you need to be careful about circular dependencies, because of course, when you have store A that injects store B, you may have store B then injects store A. Nothing that a function can't solve, but you need to be aware of that. One more thing, promise. We're going to the last few slides, couple actually. Store composition. I briefly mentioned that, but I would just want to spend a few more slides on this, because this is really powerful. Store composition is where we have two stores that achieve two different functionalities, and they composed together could lead to a third store. So in this case, we have big store on the left, which has only one computed value, which is updated array, which is taking something called self.item array, is mapping through it, and it's adding the word big to whatever thing is coming out from that array. As you may notice, item array is not defined here, so I can't really use that thing alone. Instead, data store has only one property, which is, surprise, surprise, item array, which is an array of string. Thanks to types.compose, types is again coming from MobX State Tree, I can compose data store and big store, and obtaining a big data store. So big data store, I created, I passed the initial state, which is my array of append and a sort, and at this point, it's barely seeable, but you can see that item array is append and sort array, while updated array has big pan and big sort. So I'm actually composing two features from two different components in one store that gives you the power and the features of the two stores. In order to give you some real example, because composition is nice, but when you go to real code, it's like, how can I use it? This is the zone, this is the mobile version and the desktop version, and this is the perfect example because the data is the same. So I'm not calling different API to get which are the matches that are going to be available tomorrow on my mobile or on my desktop. On the left, I want a mobile experience, so I want my scrolling to be the inertial scrolling, so you can play around with your finger as you are used to do, and your rails, we call those rails, can go as fast as you can, as your finger can go. Instead, on the desktop version, we decided that you should use arrows to navigate. This is a perfect example. Data is the same, we have two behaviors that are differently. So how we're going to tackle that? So we have 4 different stores involved into this composition. First one, most important, is data store. Everything about data, the number, the images, number of tiles, everything that was about data is there, and it's shared. It's not shared, but it's composed into two different things. On the left, we have inertial scrolling store, the one about mobile, and on the right, we have arrow scrolling store. On top of that, we have another shared functionality, which is element pooling store. So imagine it feels very obvious if you come from a mobile world, but in web, if you don't use anything, when you render a list of 1,000 items, you are rendering 1,000 items. You're not, there is no magic going on. In this case, we want instead to render only the elements that are in the view with some safe areas on the side. That's pretty standard stuff. Every mobile framework, iOS, Android, they do that automatically. In order to do that, we don't want to change that logic. We don't want to rewrite that logic for mobile and for desktop, because no matter how you scroll, that logic is the same. And so, through composition, we managed to achieve a mobile scrolling store and a desktop scrolling store using a composition of those different stores. And this is fine, and I will suggest you to use composition because it could be very useful. Last but not least, almost, mindset, derive everything. Everything I said about MobX State Tree could be, you could forget about it, but just remind just one thing. If you need to remember one thing, is about derivation. Every time you try to add a new property in a MobX State Tree store, for example, you need to ask yourself, can I derive it somewhere? Can I obtain it from somewhere else? Do I actually need it as a piece of information? If you ask yourself a couple of times the same question, you will see that you will have your model really short. You will have multiple computer properties, but computer properties are optimized, are memoized, so you need to rely on them, not on the model. Famous quote about MobX: anything that can derive from application state should be derived automatically. Takeaways: MobX helps you decoupling your code. Business logic, view, separated. Your view needs to be dumb as possible. MobX State Tree provides a structure. It doesn't actually invent anything out of the blue. It simply provides you a structure to use MobX concepts. When you set up a project, you need to shape your trees and set up the communication between stores. That's quite important. There is not a right way to do it. There are multiple differences, and you can leverage the best one that suits your project. Embrace composition, so it's useful. Embrace reactivity in general, because every time you subscribe to something manually, you are doing something that could potentially fail. If you are reacting to something, it's all different things. That's it. Slide available on GitHub, and ping me for anything. Thank you very much.